So today our topic is Routh-Hurwitz or Routh stability criterion. Uh, and actually the stability criterion comes after we form a Routh array. So Routh array is not like that kind of array which we form like n cross n array. It is not like that array. It is like a geometric representation. It is a systematic way is there, and from that we form the Routh array, and seeing the Routh array we implement the Routh stability criterion and we say that any system is stable or not, right? There are some points and some shortcuts we know to say system is stable or not, or by seeing a characteristic equation we can say system is stable or not, but that is not sufficient. So the necessary but not sufficient conditions to say that a system is stable, those are all the coefficients of characteristic equation are real. Like if I take a characteristic equation 1 plus GSHS, which is actually the denominator part. So 1 plus GSHS, 1 plus GSHS is equal to 0. That is the characteristic equation. So we can write that in like this with the coefficients of s to the power something. So an s to the power n plus an minus 1th term s to the power n minus 1 such that up to the constant a naught. So the not sufficient conditions but necessary are all the coefficients of characteristic equation should be real and positive, and there should be no missing term. Like if a1 is 0, we can say that s to the power 1th term is not present, right? So we can say that the system is unstable. We can directly say that the system is unstable. So what we have to form first, that is Routh array, the geometric representation, and that is a systematic way. So first of all, if any system is given and a feedback path is given, first of all we have to find out the system transfer function. Then seeing the system transfer function, we have to find 1 plus GSHS is equal to 0. Means this kind of representation is equal to 0. Seeing this kind of representation, I have taken an example. Okay, s to the power 4 plus 5 s cube plus 5 s square plus 4s plus k, some constant last term which is a naught, that is I am taking some constant. So first let me show the general representation of Routh array. So Routh array is just the geometric representation. In that representation we form two lines which kind of you can say that a array kind of representation. So the name goes like this. So then we first put in the left side s to the power n, like the highest order of s which is present in the characteristic equation, s to the power n, and then we decrease s to the power n minus 1, s to the power n minus 2, such that up to s to the power 0. Like this is s to the power 0th term. The coefficient of s to the power 0 is a naught actually. So up to s to the power 0. So now this is the main part where we have to map or represent geometrically all the coefficients. So then the process is, first we write an here, then an minus 1 here, then an minus 2 here, okay, then an minus 3, such that we go and up to a naught, I mean the constant term. So at first we will be getting the two rows of Routh array. Then from the two rows we have to form the next rows. So the process is, if I take this term as b1, so first of all let me show the way how we first write the two columns. That is, first an then a n minus 1, then a n minus 2, then a n minus 3, then a n minus 4 here, then here. So such a way, such a systematic manner. Okay? So after that, when we are writing b1, we have to write b1 as, like I am writing it here, b1 is equal to a n minus 1 into a n minus 2 minus this minus a n into a n minus 3 by a n minus 1. So this is actually kind of like determinant formation, but the system is not the same, kind of that. So we can take the name as array. So b1 is a n minus 1 into a n minus 2 minus a n into n minus 3 by a n minus 1, that we write here. So with the example, from the example we can find this out. So the Routh array will be like this: s to the power 4 first, then s to the power 3, s square, s to the power 1, actually s to the power 0 then. So first two rows we have to find out, that is the coefficient of s to the power 4 is 1, then s to the power 3's coefficient is 5, then s square coefficient we have to write here, 5 here, then 4 here, then k here, and here we don't find any coefficient after k, so we can take it as 0, or if we don't take it as 0, that is not any problem, not any issue. So now before s square, it is actually the b1 here, so if I want to find out b1 will be first 5 into 5 minus 4 into 1 by 5. So I just have to write that 5 into 5, 25, minus 4 into 1, that is 4 by 5, that is 21 by 5. So the next term is very important. The procedure we are finding it, that is, if I want to find b2, right, b2. So the b2 here will be, b2 is actually here, so b2 will be below 4, b2 will be 1 into 0. You always have to consider the first column. 1 into 0, sorry, 5 into k minus 1 into 0 by 5. So 5 into k minus 1 into 0 by 5, that is actually 5k by 5, that is k. So directly we can also write this, like if we are considering the column where one term is 0, so the above, if there is k or any constant, that will be coming here directly, because after the procedure that is a kind of shortcut only. So according to the procedure, b2 is equal to a n minus 1 into a n minus 1, b2 is equal to a n minus 3 minus a n, let me write it here, n minus 4, a n minus 5 is here. So b2 will be a n minus 1 into a n minus 4 minus a n into a n minus 5 by a n minus 1. Actually what I think is, finding b2 is more important, because you don't have to multiply a n minus 2 into this, right? You have to multiply this column only, a n into a n minus 5, not a n with a n minus 5. So you have to remember this very much, such that we find the whole Routh array. So if I go with the example, so I can write the next terms. So let me write it here. Right now we have find sp power 4 s cube s square sp power 1 sp power 0. Let me write it like this, you will be understanding easily. So 1 5 5 4 k 0. So this was 21 by 5, 21 by 5, and here it was k. So after that, if I want to find this term, so here it will be 21 by 5 into 4 minus 5k by 21 by 5, and the next term will be, normally it is 0, right? This term is 0, like below 5 this term will be 0. How? 21 by 5 into 0 minus 5 into k by 21. Here we find nothing, so this is 0 only. 21 by 5 into 0 minus 5 into 0 by 21 by 5. So numerator is 0, so it will come 0. Directly you can write this. This is actually very easy. So this term actually coming 21 by 5 into 4, that is 16.8. so this term is actually 16.8 minus 5k by 21 by 5. That is only. So previously I have told the shortcut, like we have to find the s naught term. You are seeing that below k, that is 0, so k will be directly come here, or you can do the steps like 16.8 minus 5k by 21 by 5 into k, this into k minus this into 0 means 0 by this term. So this into k by this term is k only, so directly k is coming. With the shortcut we can directly write as there is 0 below the k, so k is directly coming here. So this is very easy. Now we have formed the Routh array. So this portion, this is actually the Routh array where we have to implement the Routh stability criterion. Now understand it very easily. So the Routh stability criterion, which is the every element in the first column of Routh array should be positive. Like if any term 1 5 21 by 5 21 by 5 into 4 minus 5k by 21 by 5 and k, if any of this is negative, so the system will be unstable. If all the terms of the first column of Routh array is positive, then it will be stable. This is the main thing in Routh stability criterion. And the number of sign changes, is the number of poles occurring the instability, right? So if suppose this value is minus, this value is negative, or let me take this value is negative, this value is actually we are seeing positive, let k is positive. So number of sign changes is here positive to negative, one sign change, negative to positive, another sign change. So 2 sign changes. So with this negative we can directly say that the system is unstable, but the number of if there is number of poles occurring instability, that answer will be 2. Now another thing, we have known the stable and unstable condition, but the marginal stability condition, that is if a row of Routh array is becoming 0, then the system will become marginally stable. Now very popular questions are asked, find out the value of k in GATE and college examination, everywhere these kind of questions are asked, engineering service also. find the value of k for which the system is stable, unstable or marginally stable. So if I take marginal stability condition, then 16.8 minus 5k by 21 by 5 is equal to 0. This will be 0 because this is already 0. So this is multiplied 0. So k, I am directly writing that 16.8 by 5. So this is the answer. The questions comes like this and this is the answer. Now if they ask find the value of k for which the system will be unstable, that can be, this one can be negative and k can be negative. So k less than 0, this is 1, and from this we will find a value of k. So two values of k or any range of k we will be finding and saying that for these values of k system will be unstable. These kind of questions actually asked. So thank you for watching, and please subscribe and share with your friends, and it will be very helpful to them. And Routh-Hurwitz criterion is very important for understanding root locus also. That will be my next video.